the measured radiocarbon dates with the expected zodiacal dates, and the agreement is extraordinary. So I guess that is unwelcome because, at a stroke, perhaps lots of ideas now need to be, well, essentially abandoned or rethought.
Hello, good morning to everyone. Welcome to Star Views again. And today I'm here with Professor Martin Sweatman, author of Prehistory Decoded. Martin Sweatman is a professor of science at the University of Edinburgh. He has a PhD in theoretical physics at the University of Bristol. He wrote hundreds of scientific peer-reviewed articles in different disciplines. And the areas that we are going to talk today is related to astronomy in the past, in prehistory particularly, and also to an archaeological site that was discovered in the 60s but made public only 15 years ago, Göbekli Tepe. Today is the chance to talk more in depth about Göbekli Tepe with Professor Sweatman, whom I thank very much. Professor, welcome.
Hello, yeah, and thank you for that kind introduction, David. Nice to meet you.
Göbekli Tepe is a site that defies the knowledge that we have of human civilization and our prehistory. It's particular because actually predate what we know about the start of our civilization, at least of 1,000 years. So it is a very interesting site. And Professor Sweatman developed an hypothesis about this archaeological site in his book, Prehistory Decoded. So, Professor, what is particular about this site and what did you find out about it?
Well, there's a lot to talk about. I guess the key thing is that it was very unexpected when it was discovered over 20 years ago now, that the level of organization needed to build it, the sort of the type and degree of the symbolism at the site and the scale of the site was completely unexpected for that time period. And the time we're talking about is, well, probably 9,500 BC and probably older than that too. So it's kind of like an anomaly almost. And so that makes you curious as to how this got constructed and why. And so something that I was interested in was trying to understand that, and particularly by trying to understand the symbolism that's carved onto these pillars. So these pillars are arranged in great stone circles on top of a hill in Turkey. This is where the site is. So by trying to understand the symbolism on the pillars, we might be able to understand why the site was constructed. Now, the other really crazy thing about it is that archaeologists have been looking for, let's say, what we might call the origin of civilization for over 100 years, and it's led them to this part of the world in the region of Turkey or Mesopotamia, this region called the Fertile Crescent. And so they've been homing in on well, actually the origins of agriculture, which is what they archaeologists associated the origin of agriculture with the origin of civilization, essentially, or there's something called the Neolithic Revolution is maybe a better term. But so they were searching for the origins of this sort of Neolithization process. And what they found was Göbekli Tepe, which was a complete surprise to them. They weren't expecting to find this kind of site right at the beginning of this process. So it's saying something very interesting about what happened then. It's saying something interesting about the origins of our civilizations.
It's so basically we are talking about a megalithic site that is uncovered only for, if I understand correctly, at this moment only 10% of what of the whole size of it. So 90% of it is still underground, correct?
Yes. So archaeologists have been excavating it for a few decades now, and so far there's around about 10% has been uncovered.
Right. So, and there are basically is the structure of this site is such that is made of enclosures, circles, so to speak. And in the middle of this of the circles and all surrounding the circles, there are slabs of stone that at times even weigh more than 15 tons. So something that is very difficult to imagine that somebody could build. And at a time when we know, or we think that we know, that we were hunters gatherers.
Yeah, that's right. So, a little bit more detail about Göbekli Tepe. That there are, it's quite a large site. As I say, only roughly 10% is excavated, but it covers, the extent is very large, maybe a few hundred meters by about 100 meters, so it's quite big. And the site is on top of a hill on in southern Turkey. And so far, the excavated portion consists of several, let's say 4 or 5 enclosures, as you described. These are the sort of these are formed by giant megaliths arranged in a circle and then enclosed by a rough stone wall. And it's the symbols that are written onto these pillars. And so there are four. It's like having several Stonehenge monuments on top of a hill, but it's several times the age of Stonehenge.
Also, apparently, and maybe we go back to this later, but the whole site was buried on purpose by, we don't know actually who built it or who buried it, but it came to us almost intact because it was preserved by the time. Is it correct?
Yes, it is preserved, but the latest thinking, as I understand it, is that it may not have been deliberate. So the site was
Okay.
covered over by debris. Um, and I think that the latest thinking is that this might have been accidental. So the archaeologists are proposing recently that there are these stone circles, as we've mentioned, and there are probably more than the number that have been uncovered so far. So there are 4 or 5 at the moment, but there are probably more than that. And then what seems to have happened is that the people lived there in smaller buildings in and around the temples. And what seems to happen, and we see this at other archaeological sites from that time period and a bit later, the sites like Çatalhöyük. But what happens is that the people seem to have, they build their houses, and then maybe after 100 years they demolish that house or it falls down and they build another layer of houses.
Okay.
And so the layer of housing builds up and up, and this is all in between the what we might call temple structures, or these enclosures anyway. And then they got to a point where, for some reason, according to the archaeologists' latest thinking, there was kind of like a landslide of these houses which are built on top of each other into the enclosures, sort of partially burying them. And so this is the latest thinking of how they got preserved. It may have been entirely accidental.
So, but the interesting thing about this is that apparently there are signs of very deep astronomical knowledge and symbolism attached to it, because on these stones there are bas relief and high relief with pictures of animals. Professor, what is the mainstream, so to speak, interpretation of them, and what is yours?
Okay, so the archaeologists, to my mind, don't really have a very satisfactory explanation for what these symbols are. There's a mixture of symbols. We have some abstract symbols which almost look like letters, like there's like a symbol in the shape of an H. And then we have some what are clearly astronomical symbols. So we have something which looks like a sun and a moon, so like a disc and a crescent shape together. That's on another pillar. And then there are lots of these animal symbols as well. So animals in different poses, quite a few snakes as well as these different kinds of animals. Now, as I say, the archaeologist explanation is that these are animals. Well, they could be animals, or they could be representations of some kind of mythology, representing mythological creatures. And perhaps there are different groups of people that favor different animals or different mythologies. And that's pretty much as far as the conventional, let's say, archaeological story goes. But it entirely ignores the obvious astronomical symbols that I just just mentioned. So there is this what looks quite clearly to be a sun and a moon symbol together. But there's also another pillar called, well, it's labeled pillar 43, but it's more commonly known as the vulture stone for various reasons. But there's another pillar which has another one of these disc shapes, these circles on it, surrounded by animals or animal symbols. And so if this disc shape is the sun, as we think it might be, because on another pillar we see it next to a crescent symbol, which looks like a moon, then if this disc is the sun, then perhaps the animals are constellations. That's a hypothesis. Then this is really where I started. So with this idea that these might be constellations. And on this pillar 43, one of the animal symbols is a scorpion. So then immediately you think, well, maybe they're using similar or the same constellations to the ones that we still use today, even though it was at least 11,000 years before our time. And so then what I try to do in the papers that I published and in my book is to try and decode, well, if these are constellations, what could this mean? And so I eventually think I worked out, or I propose anyway, that this pillar 43 is representing a date using constellations relative to the position of the sun on the summer solstice. And they've also recorded, I think, the constellations for the other, for the winter solstice and the equinoxes. So they can represent a date. And it turns out that date, if you use astronomical software to try and estimate or calculate the date using precession of the equinoxes represented on this pillar, it turns out to be very close to an event known as the Younger Dryas impact, which is suggested to be impact of a comet on Earth, which had very dramatic consequences at that time, and which would make a lot of sense. If this event happened, and it almost certainly did, I think, then it would have had dramatic consequences. It's something that people might have tried to record in some kind of structure, or maybe some kind of temple, perhaps. So it kind of makes sense as perhaps being the motivation for the construction of Göbekli Tepe, this dramatic cosmic impact event.
Cosmic impact event. Before we go into the Younger Dryas that you just mentioned, what is can you say a few words about the precession of equinox, just to understand what kind of things we are talking about?
Well, if you look at the position of the sun relative to the stars on the summer solstice, for instance, then you'll see that if you measure that position, you'll see that it changes very slowly. Over thousands of years, the position of the sun will track through a constellation. And so by representing the position of the sun relative to a constellation, you can actually record a time with an accuracy of, well, it depends how accurately you draw the constellations and the position of the sun. In theory, or in principle, you could even achieve an accuracy of, say, 1 year. But in practice, because we don't know exactly how these animal symbols match the constellations, probably we can estimate the date that's represented with an accuracy of about 100 years or so. So yeah, it's if you represent the position of the sun on the summer solstice, it changes very gradually. Over a person's lifetime, let's say 70 years, that position will change by an amount roughly equal to twice the width of the moon. So over one person's lifetime, you can actually observe, you can observe a difference of, say, a moon diameter in the position of the sun relative to the stars. So over a person's lifetime, this is an effect that could be and probably was noticed by ancient people long before, well, conventionally it's thought that Hipparchus of the ancient Greeks in the 2nd century BC discovered this effect. But there's no reason why people could have discovered it many thousands of years before that. It's quite an obvious observable effect.
Although, so we are basically saying that we have to predate the knowledge of the precession of the equinox of about 8,000 years. So basically, by work of comparison between the pillars and the animals depicted on the pillars, you were able to establish a date that is roughly 10,900 before Christ. That date is very interesting also because, as you said before, we had this event, climate event, the Younger Dryas, which was a sort of mini ice age that lasted about 1,300 years. And the scholars, usually the mainstream scientific community, has a gradualistic opinion about why the Younger Dryas developed, but you have a different idea, Professor. What is that?
Uh, yeah, so this is something that this isn't my idea exactly at all, really. So this is something that's been researched by a group of scientists, mainly from America, known as the Comet Research Group. There are over 60 people associated with this research sort of grouping, and so they proposed back in 2007. It was published. They proposed that this Younger Dryas period, this mini ice age, was caused by a comet impact. So along with the impact, they propose that there are various effects, including this dramatic drop in temperature, which, as you say, lasted over 1,000 years. This is sort of mini ice age known as the Younger Dryas period. But also that it could have resulted in changes in human culture, perhaps changes in human population, and also at around that time in the sort of archaeological record, we see that there are what are known as megafaunal extinctions. So many species of large animal became extinct at around about that time. And problem is that the dating of these extinctions isn't known accurately enough to know whether it occurs right at this Younger Dryas, the beginning of this Younger Dryas period, or whether these extinction events are more spread out. But nevertheless, this comet impact theory suggests that many of these extinctions are related directly to this cosmic impact event. So it's a very dramatic event that affected much of the northern hemisphere of Earth.
Catastrophic events, however, are not very welcome in the scientific community, if I understand.
Yes, so I mean, there's a lot of sort of science history to that position. You can go back thousands of years, but if we just go back to sort of the beginning of the scientific revolution, then you have the religion of the day, at least in Europe anyway, Christianity, which ruled out cosmic impacts, and then the scientific revolution took over, and then we had innovations such as the sort of invention of the basics, sort of fundamentals of geology, which are about erosion and deposition and sedimentation. And then later on, we had sort of Darwin's theory of evolution came along. And so over hundreds of years, this sort of gradualistic view of change on Earth developed, which essentially ruled out these dramatic cosmic impacts. And at the same time, we didn't know very much about asteroids and comets in near Earth space. So it wasn't recognized that these impacts could affect Earth. And it's only really been in the last 50 years that this sort of gradualistic view, which underpinned much of science, particularly geological science and archaeology, it's only really the last 50 years that it started to change. And it was the Chicxulub impact, which is thought to have been responsible for the demise of the dinosaurs, which really changed things dramatically. So that was about 40 years ago. And so since then, we've got more evidence. We've discovered more craters on Earth. We've discovered many, many more asteroids in near Earth space. We now know a lot more about comets, particularly large comets that come from the outer solar system. There have been some in the news recently. And so now we do recognize that impacts do happen on Earth. But still, there is this sort of pervasive view that it's unlikely that there could have been a major impact recently within this time scale of, say, human civilization. And so this Younger Dryas impact theory, which suggests a comet impact only 13,000 years ago, is really challenging this sort of conventional view of how often large impacts can happen on Earth.
Because the last impact that we acknowledge that has happened is the extinction of the dinosaurs 66 million years ago.
Yeah, well, that's probably the last one that's associated with an extinction event.
With an extinction, right?
We do know that there must have been large impacts on Earth since then, because we see the crater record. There are several large craters over the last few tens of millions of years. And now, because we have a much better idea of how many asteroids there are, we expect a relatively large impact, say with a 1 kilometer sized body every roughly a million years. But still, the possibility of a fairly large impact only, say, 13,000 years ago is controversial, because it was thought to be unlikely, it's unexpected, but the evidence is very strong that this happened.
So you connect this catastrophic impact at the beginning of the Younger Dryas with Göbekli Tepe. And also you say that, I want to read actually a quote from your book, Prehistory Decoded. You say, it seems that people who constructed Göbekli Tepe over 11,000 years ago, and the person who sculpted the Lion Man 40,000 years ago, had a common understanding of the night sky and the shared aspects of the same mythology. So basically, you have this hypothesis that what we find in the prehistoric caves in Europe, in France, in Germany, and Göbekli Tepe, there is a connection there. What is it?
Yes. So after decoding, or what I think Göbekli Tepe means, then we have all these animal symbols which represent the constellations, and they're quite similar to our modern set of constellations. So we see all these animal symbols at Göbekli Tepe with this sort of astronomical significance. We also see many animal paintings in the caves of prehistoric Europe. So if you go back into what's known as the Paleolithic age, this is now before the Younger Dryas event. There are many very well-known, very famous caves with these animal paintings on: Lascaux Cave, Chauvet Cave, and so on. And so now, with this understanding from Göbekli Tepe, we can try to apply the same, if you like, hypothesis to these other animal paintings, and we can actually do a proper scientific test that compares the known ages of many of these paintings. They've been their ages have been measured through radiocarbon dating. So people have taken little samples of the carbon in the paint of many of these animal paintings in the caves, radiocarbon dated them, and we can compare those radiocarbon dates with the expected age based on this, what I call zodiacal theory or zodiacal hypothesis. And we find that the agreement is amazing. It's really incredibly strong. And so from a scientific perspective, I'm forced to conclude that they were essentially using the same kind of system over tens of thousands of years in Paleolithic Europe. So for instance, suppose the summer solstice was in Capricornus. So in other words, suppose the sun on the summer solstice was in the constellation of Capricornus, or what we would see as Capricornus. Right. What I propose is that at that time that they would be painting a bison or a bull on the walls. And suppose the sun on the summer solstice or on the winter solstice, say, was in the constellation Leo, then they might paint a horse. That's the zodiacal symbol I think they were using. So this is what I call the zodiacal theory. And the agreement is amazing. So, as a scientist, I follow the evidence, and so I'm forced to conclude this is almost certainly correct. The same kind of system they were using in Paleolithic Europe also appears at Göbekli Tepe, and I think we can actually follow that evidence. It didn't stop at Göbekli Tepe. I think this system of writing dates using precession of the equinoxes and the constellations carried on probably right up to and beyond and into the Bronze Age in several different civilizations.
So basically, you're using a statistical model that is completely scientific, even though you cannot have, let's say, the smoking gun or the 100% certainty. You say that by your statistical model, you have one chance out of 2 billion possibilities to be wrong or something like that. Am I correct?
That's right. So that's when we compare, let's say, one of these paintings with its expected when we compare the expected zodiacal age with its actual radiocarbon age, let's say for one of these cave paintings, the chance of agreement is about 1 in 3. But we have many, many paintings to test. There are something like 30 or 40 different paintings that have been well dated. And so when we look at all of those results, we get this probability of a third multiplied by many, many, many times. And eventually you end up with this statistical result of about a chance of about 1 in, I forget the exact figure, 1 in a billion or 2 billion, something like that, of this happening by pure chance.
Right.
So almost certainly it wasn't pure chance. It's almost certainly not just chance, and almost certainly this hypothesis is correct.
So at the moment, this is the best scientific hypothesis that we have for the interpretation of these cave paintings, in connection also with Göbekli Tepe, which is incredible, because if this is true, as it seems to be, it means that the zodiac signs that we use today go back 40,000 years, almost in the same way, except for a couple of signs that you mentioned before. And also, we have to think that 40,000 years ago, they already knew the precession of the equinox, which is something quite incredible to me, because if you think about it, the sky is moving only 1 degree every 72 years. So you have to be, it's true also that, once upon a time, maybe the sky was more visible than today. However, you have to have some degree of attention to understand that.
Yeah, so if you go back to the times when these people were living, they would have been much more in tune with the sky than we are. We apart from astronomers, we hardly, professional astronomers, we hardly paid the sky much attention at all. But their life would have been probably quite closely linked to what was going on in the sky, because all of their resources are seasonal. Everything that they need is seasonal. And the sky is seasonal. We have the solstices and equinoxes. And so they probably were observing the sky for different reasons, for keeping track of time, perhaps for navigation as well. So it makes very good sense that they were good naked eye astronomers. And there's other evidence for this as well. There's evidence that they were keeping track of phases of the moon and developing calendars based on phases of the moon. So it's not really a surprise that they were interested in astronomy. Now, the possibility that they could have defined constellations that we still use, well, that's the really amazing thing, if it's true, because we're talking about 30, 40,000 years when we're using more or less the same constellations, or they had different symbols. Still, the groups of stars and the patterns they were seeing, it seems, were very similar. So that's the incredible thing. So how that can have happened? Well, people might argue, well, that's just impossible, that something could have been fixed for so long. But what I would say against that is, well, the stars' positions are nearly fixed over that time. So you do have something that is like a fixed reference. And the other argument I would say in favor of this idea is that these cave paintings, the styles of these cave paintings hardly change over this period, maybe 30,000 years. And so clearly there is some kind of cultural handing on of information, of painting styles that's going on for an extremely long period. And so if people were handing on these painting styles, because if you look around the world at the paintings of prehistoric peoples, they're all very different. Every area, every region has its own particular style. And Paleolithic Europe is no different, that has a particular style. So this culture must have been handing on their painting techniques and styles for 30,000 years. So if they can do that for their painting style, then why not for their astronomy? It makes sense to me.
No, absolutely. It's just that sometimes there is a Zwift in our knowledge of the past that is quite difficult to accept, especially if you maybe built a career on certain paradigms. And this is why probably you met a lot of pushback from your colleagues in the scientific community.
Well, yes, particularly I would say, in archaeology, archaeologists, there's a particular group of archaeologists that have been studying cave paintings and rock carvings and rock paintings, outdoor rock paintings since they've been discovered for hundreds of years. So, there is already a sort of academic community, and I would say that apart from the radiocarbon dating, there isn't really a lot of science. Well, there isn't any real science in the interpretation of these cave paintings. It's all very much guesswork and speculation, and it's very it's just a suggestion, really, the current interpretation. So what I've done is actually scientific. It's a rigorous scientific exercise that compares the measured radiocarbon dates with the expected zodiacal dates, and the agreement is extraordinary. So I guess that is unwelcome, because at a stroke, perhaps lots of ideas now need to be essentially abandoned or rethought.
The Younger Dryas Impact paper was accepted on Earth Science Reviews this year, so it's quite is happening now. But did you have the impression that the attitude of the scientific community towards your ideas in this respect changed a little bit, or you find this still the same kind of pushback that you had maybe 5 or 10 years ago?
But yeah, I mean, I could see, I'd read all of these, over 100 papers, this to and fro argument about this comet impact theory for the origin of the Younger Dryas period. And I could see that one side really had a very good case. That's the proponents, and that the opponents were really struggling and were coming up with some what I could see as poor ideas, poor arguments against the theory. And so, despite what I could read in the papers, as I read the papers, the evidence was very strong. My impression of the wider community was that this idea still wasn't widely accepted. So I think it needed, or a good review paper of this whole debate was needed. Now, I didn't review the whole debate because there are lots of the consequences of the impact, like the climate change, the megafaunal extinctions. That's really a little bit beyond me, but the geochemical evidence for whether the impact happened, that was something I could review, and so that was where my contribution was.
Professor, to finish our conversation, I want to go back for a second to Göbekli Tepe, because from your book, I understand the what and the why. Why? Because we have this megalithic site describing a catastrophic event in the past. However, my questions here are more who and how. Did you think about some possible explanations? Who might have built this megalithic structure 10,000 years ago, 11,000 years ago, and how?
The how, I don't really know. That's not something I can give you any answers to. I think probably the sites, the archaeologists working at the site will have the best information as to how they actually did it. And also, who, I would be speculating again. I think it's very difficult to know exactly who built it. Probably, I would suggest it's most likely the local people at the time. So we know that one of the comet fragments from this Younger Dryas impact, we know that one of the fragments exploded in probably what was an airburst, so above ground level, only about 100 miles south of Göbekli Tepe. Well, we know that at least that a settlement that's about 100 miles south of Göbekli Tepe was completely destroyed. This is a place known as Abu Huraira. So it's one of the world's very first villages, and that was destroyed by this impact. That seems very clear. So the people in the region very likely witnessed this event, very likely affected by this event, quite in very dramatic ways, probably. And so I suspect it was just the survivors, the people that were left over, who struggled on and witnessed this and continued and wanted to memorialize and make sure that future generations remember or were aware of this event. I suspect it was really just those survivors that began the construction at Göbekli Tepe. That's my suggestion anyway.
But you have a very interesting idea about the how the human civilization started, because actually the difficult thing for interpretation of Göbekli Tepe is the fact that that site implies an advance, so to, no, I don't want to, maybe advance is not the right word, but a civilization that is able to accomplish such an achievement, although we are still talking about hunter-gatherers, and this comes 1,000 years before the invention of agriculture, which scholars think that, you know, started the human civilization. So how do you explain this contradiction?
Well, that's a really great question. So that's really what, how do we understand Göbekli Tepe? What does it really mean? Does it represent something related to the origin of civilization? As you say, agriculture, the origins of agriculture haven't been found precisely at Göbekli Tepe, but they have been found very nearby in the neighboring region. Yeah, and how did people suddenly construct this amazing site? Well, if you look back in the archaeological records, at least some of the signs, some of the expertise that's needed is already in evidence, or at least partially in evidence in that region. So before the Younger Dryas event, people in that region, they're known as the Natufian people, they just started to settle down and create villages. As I just described, there was a village called Abu Huraira, which was destroyed. So they'd already settled down, and they were still hunter-gatherers, very likely, but they'd started to create settlements. They were, we know from another site called Tel Caramel, they were able to fashion great big blocks of stone and to build towers even. So there is evidence of stone towers being built even before the Göbekli Tepe or the Younger Dryas event. So they've got some of the megalithic skills. They've settled down, so probably they're starting to experiment with agriculture. So what's missing really is the scale and the level of organization that's needed, because Göbekli Tepe is probably going to turn out to be a fairly large settlement, larger than anything that we've seen before then. And the level of organization that's needed to construct several temples and to build houses around them, we haven't seen anything like that before. So really it's the sort of the organization, and well, we hadn't seen this particular style of carving the pillars before as well. So that skill would need to be developed, but there's probably time for that. So anyway, the way I see it is, what I propose anyway, is that this catastrophic event probably generated a new religion, maybe some kind of comet cult. And a religion is something that can catalyze people, to get people to work together, can organize people. So I suspect that through some kind of new religion, people became more organized. They had the motivation to construct a place like this, using skills that they were either had or were starting to develop in the preceding period.
Certainly, Professor, what Göbekli Tepe is telling us is that there is so much that we still don't know about our past, and who knows if in the future we are going to be able to collect enough data to explain all the questions that we might have about our prehistory, history of humankind, and the beginning of civilization. Professor Svetman, thank you very much for your time today. I would like to recommend your book, Prehistory Decoded. I'm going to actually put the link in the description of the video here under the video. And Professor, thank you so much.
No, you're very welcome. Thank you very much.
Thank you. Please like, share, and subscribe. And till next. Thank you so much.
Thank you.